Hello everyone, this is Negali Patel from New Alger Institute of Engineering and Technology. In today's lecture, we are going to discuss about Poisson distribution. So let's get started. A random variable x is said to follow Poisson distribution if the probability of x is given by e raised to minus lambda, lambda raised to x upon x factorial, where x is from 0, 1, 2 up to infinity. And lambda is called the parameter of distribution. Poisson distribution is also discrete probability distribution with parameter lambda. And we can also say that the Poisson distribution is limiting case of the binomial distribution under the following condition. And these conditions are: first, the number of trials should be the infinitely large. That means n tends to the infinite. The probability of success P for each trial should be the very small. That means P tends to the 0. And NP equals to lambda should be the finite, while lambda is equals to constant. Let's see some examples for the Poisson distribution. So the number of defective bulbs produced by the reputed company, number of telephone calls per minute at a switchboard, number of cars passing a certain point in a 1 minute, number of printing mistake per page in a large text, and the number of persons born blind per year in a large city. So these are some real life examples of the Poisson distribution. Now let's see some assumption or the conditions for the Poisson distribution. So first is that the random variable x should be the discrete. The number of trials n is very large. The probability of success P is very small. That means P tends to the 0. And P is equals to lambda is finite. The second, third and fourth condition we have already discussed over here as well. And the fifth is that the occurrences are rare. Now, let's discuss some constants of the Poisson distribution. So the mean of Poisson distribution is equals to the lambda. Variance of Poisson distribution is also equals to the lambda. And standard deviation, that is the square root of variance, is equals to the root lambda. Recurrence relation for the Poisson distribution is given by P of x plus 1 is equals to lambda upon x plus 1 into P of x, where P of x plus 1 is e raised to minus lambda, lambda raised to x plus 1 upon x plus 1 factorial, and P of x is e raised to minus lambda, lambda raised to x upon x factorial. So by solving this two equations, we can get this formula: P of x plus 1 upon P of x is equals to lambda upon x plus 1. Now let's see some examples for the Poisson distribution. So the first example is that a book contains 100 misprints distributed randomly throughout its 100 pages. What is the probability that a page observed at random contains at least 2 misprints? Assume Poisson distribution. So it is already given that we have to assume the Poisson distribution. Book contains the 100 misprints distributed randomly through its 100 pages. So the total number of pages of the book is 100. And in this 100 pages, the 100 misprints distributed randomly. Now here we want to find out the probability that a page observed at random contain at least 2 misprints. So the number of misprints is denoted with random variable capital X. So we want to find out P of x greater than equals to 2. So that is equals to 1 minus P of x less than 2. So that is equals to 1 minus P of x is equals to 0 plus P of x is equals to 1. Now 1 minus P of x is equals to 0, that is e raised to minus lambda, lambda raised to 0 upon 0 factorial plus e raised to minus lambda, lambda raised to 1 upon 1 factorial. In order to get the value of P of x greater than 2, we must require the value of the lambda. So lambda is equals to nothing but that is equals to n into P. n is equals to 1 as we are observing the one pitch, and the p is equals to the number of success, and that the probability of success. And over here, the probability of misprint is the probability of success, because we want to find the at least 2 misprints for the given pitch. So 100 misprints distributed randomly throughout the 100 pitches. So P is equals to 100 by 100. So lambda is equals to 1 into 1, and that is equals to 1 only. So the value of lambda is equals to 1. So 1 minus e raised to minus 1. 1 raised to 0 is 1, and upon 0 factorial is also 1. E raised to minus 1. 1 raised to 1 is 1, upon 1 factorial is also 1. So 1 minus 2 into e raised to minus 1, and that is equals to 0.2642. So this is the probability that page observed at random contain the at least 2 misprints, and that is equals to 0.2642. Now moving to the next example. It is given that the probability that person catch swine flu virus is 0.001. Find the probability that out of 3,000 persons, exactly 3, more than 2% will catch the virus. So over here, the y is equals to 3,000. P is the probability of success, and here the probability of success is the probability that a person catch swine flu virus is 0.001. So lambda is equals to n into p, that is the 3,000 into 0.001. So the answer is 3. Now here the value of n is very large and the value of p is very small. So for that reason, we are applying the Poisson distribution. Now, the first case is that exactly 3% will catch the swine flu. So P of X is equal to 3. Here the X is the number of persons that catch the swine flu virus, and that is equals to e raised to minus lambda raised to 3 upon 3 factorial. The value of lambda is also 3, so e raised to minus 3, 3 raised to 3 upon 3 factorial, and that is equals to 0.22. Moving to the next case, more than 2% will catch the virus. So second is more than 2% will catch the virus. So probability P of X greater than 2, and that is equals to 1 minus P of X is equals to 0 plus P of X is equals to 1 plus P of X is equals to 2. So 1 minus e raised to minus lambda raised to 0 upon 0 factorial plus e raised to minus lambda raised to 1 upon 1 factorial plus e raised to minus lambda square upon 2 factorial. 1 minus e raised to minus 3 raised to 0 is 1 upon 0 factorial is also 1. E raised to minus 3, 3 as 3 raised to 1 is 3 upon 1 factorial is 1. E raised to minus 3 square upon 2 factorial. So 1 minus e raised to minus 3, 1 plus 3 plus 9 by 2. So that is equals to 1 minus e raised to minus 3, 2 plus 6 plus 9 divided by 2. So that is equals to 1 minus e raised to minus 3, 17 by 2. So that is equals to, so P of X greater than 2 is equals to 0.58. So this is the probability that more than 2% will get the swine flu virus. So this is all about today's lecture. In next lecture, we will solve some more example on the Poisson distribution. Till then, keep exploring and thank you.